this computer. Okay, cool. Well, hi, Perry. Welcome to the Ozeki Journal Club.
Hey, Carlos.
Hi,
hey, Marcio.
Hi.
Good afternoon for you. Good morning for us. Thanks so much for joining us. So today we have Marcio joining us, which is very exciting. He's someone we met through a friend of a friend who is quite knowledgeable in some interesting topics related to blockchain. So we'll be happy to get his expertise. And we just met, so I think we're gonna maybe spend the first few minutes getting to know each other. Very curious to see, what kind of stuff you've been interested in. So we're Perry and I run a very small consulting service for deep tech companies. So we are trying to offer them some expertise in machine learning, blockchain when we can. And in order to do that, we obviously have to stay on top of technology as much as possible and of science. So we basically read papers, and we decided to share our discussions when we read papers and articles on YouTube. So that's what we've been doing for a few months now. Sometimes we're lucky enough to have someone who knows more about something than we do, which is a lot of people. So we're happy to get someone with more knowledge. So that's our side. And Marcio, whatever you want to share with us, please.
Well, I'm just a guy on the internet.
Yeah.
I'm a developer, software engineer. I'm working in Rust.
In Rust?
If you know anything about that language?
Not so much. I saw though that you have some repos in Haskell.
Yeah, I did something in Haskell for my master thesis.
How was that? I'm curious about that because I've always been putting off learning Haskell.
I think that for that specific application, Haskell was very, very nice.
Mm-hmm.
I ended up programming some translation between logics.
Mm-hmm.
For that case, it was very fast to do.
Because I've seen I do a lot of computational biology and machine learning stuff, and I've seen some libraries in Haskell for doing that kind of thing, like data handling and all this stuff. But I kind of wonder if for that kind of application, it's actually useful compared to Python, something like that,
Yeah, I guess that for data manipulation, translation, these sort of things, it should be one of the best languages, probably.
Oh, okay, so I'll give it a look.
And what was your master's in?
My master was, I don't remember.
It's all right.
It was about, I have to optimize translation between a model logic to a first order logic. Yes, I think there were many ways to do the translation, and I have to sort of find
the optimal one.
A better way.
Okay, so it was very deep computer science,
very, very theoretical, and yes, and a bit of practical.
Cool, very cool.
You did it in Argentina?
I did it in Cordoba, Argentina.
In Cordoba, Argentina. Nice. Very nice. Cool. So today, I guess the topic is Polkadot and Substrate parity, and that's some stuff that you've been looking at lately. So Perry and I did a bit of preliminary reading. It's, I guess, very difficult to get a grasp on how things work.
I was watching your last episode of Proof of Stake.
Oh yeah, exactly. We started looking into proof of stake. I mean, it's been in the background for a long time, but we're trying to get more into the details of it. Mm-hmm. So that was something that we were kind of also curious about, that how Polkadot deals with that. And also just in general, how all the parts work. So I guess I'm wondering if you can give us a very high level overview. Maybe we can look at some pictures on a website that you find useful and kind of have a discussion based on that.
Yeah, sure. I'm not sure if I can share something.
Your co-host, no?
My Zoom is.
Oh, right. Are you on the browser Zoom or on the standalone?
The standalone. I think that I have two clients installed.
Worst case, we can share something and you
Or
can.
maybe if you can go to the website of
Yeah, sure. I'll share my screen.
Polkadot and share the screen and sort of wander around, and I might help you.
Oops.
Carlos, this is very, very dangerous, Carlos.
Oh no, I'm sharing my Proton mail.
Any new paper?
All right.
So you're a PhD student, Carlos, right? And
Yes, I'm about to defend my thesis.
Cool.
In computer science.
And you, Perry?
I graduated actually. You can call me Perry. Yeah, I graduated. I guess I defended in July.
Mm-hmm.
So I was, but I was a PhD student. I did my PhD in physics though.
Cool.
Actually, that's where I met Alessandro.
Yeah.
And actually, you haven't met Alessandro though, but he's done a podcast with us as well.
He did an episode with us actually. Yeah, you should watch it.
And you can see his
as
face
a random
finally.
guy on the internet, by the way. We didn't say that where he works, because that was also I might have to cut this now that I realize, but okay. Anyway, so I'll go on Polkadot. So I read part of the Polkadot white paper, the original one. I don't know if you think that's a useful.
I think it's better to go to the main website.
.network.
Yeah.
Oh, there's proposals.
I think that you can go to the end, to the footer. The documentation, in community documentation. I don't know why I know this website so well.
Uh-oh, Brave thought it was missing.
Okay. There, probably you can go to learn. Yeah, I think that there we can see an overview.
Cool.
Of everything.
Architecture.
Maybe we can start with even very general questions.
Yeah.
Maybe Marcio, you could tell us like what's Polkadot's vision say? Like what are they trying to accomplish very broadly?
Yes. Polkadot is like a meta protocol. It's like it's meant to be something more general than Bitcoin, of course, and more general than Ethereum.
Okay.
And yes, also they wanted to to solve the scalability problem.
Mm-hmm.
So they implement sharding, like sort of like a Ethereum version 2 is supposed to do.
Mm-hmm.
Yes, so if you go to architecture, you will see that Polkadot basically consists of a central chain that they call relay chain. The relay chain has like a slot, like I think it has like a 100 slots, and where you can connect what they call parachain. A parachain is the name in Polkadot for shards.
Okay.
That what is that?
I mean, this is this one is very confusing. Maybe I think there's a picture on the wiki now.
It's finally gonna start making sense to me though, right? Like you have a relay chain in the middle, parachains plugging into the sides.
Right.
But yeah, if there's a simpler picture.
Maybe scroll down. Maybe it's on this. Okay, no pictures here. Okay, well, I don't know.
No, okay. I mean, I think we got it. So there's a central chain that's sort of coordinating.
Yeah, there is a central chain and surrounded of around about 100 parachain.
Yeah.
That can be very generic. Can be sort of Ethereum chains, or can be, I don't know, anything that you can imagine built in.
Mm-hmm. And is the goal for Polkadot to replace, say, all other blockchains and have these parachains replace certain features, or is the goal, for example, for Polkadot to be some connection between existing blockchains and other blockchains?
I think that the goal is to be sort of to facilitate the connection between all these blockchains,
Okay.
between Bitcoin, Ethereum, and DeFi blockchains, and identity blockchains, Oracle blockchains, all of that. And the idea is that all these blockchains will be connected as parachains to the relay chain. And they will be all executing in parallel, like if they were like a different CPUs, sort of.
Right.
Yeah. So what do like pre-existing parachains gain from connecting to the relay chain? Like I would imagine one aspect is you have, I think like, maybe we'll talk about Substrate where you can easily build chains with certain properties and automatically become parachains. But another...
You know a lot.
Well, I'm probably not there, but I'm curious, like, so...
We know keywords like...
Yeah, I think parachain, relay chain, and proof of stake. But so I'm wondering, like, is there any benefit in terms of scalability, for example, for Ethereum to become a parachain on Polkadot? Or is it really more for newly made chains that are directly built into Polkadot that are going to get this kind of benefit?
Yeah, I guess Ethereum can sort of profit from connecting to Polkadot ecosystem, because it will be able to connect to all the blockchains that are only connected to the relay chain in Polkadot. Okay, then once the parachain connect to the relay chain, they can send message between each other. And they can, yeah, that's the main advantage, to be able to send message to all the different parachains in Polkadot.
Interesting.
Is Ethereum currently connected somehow or no?
I think no. They are building bridges to Ethereum and to Bitcoin. I think that the one for Bitcoin is ready already. What they have in the moment are parachains that support Ethereum virtual machine.
Oh, okay.
So basically, yes, all the people from the Ethereum community can deploy the smart contracts in these parachains.
I see.
Yeah.
I don't know if Carlos, you have another question, or I can follow up.
I guess I have a slightly more specific question. Maybe you can walk us through the steps of going from a transaction in a parachain into the relay chain. Like, what kinds of things does the relay chain have to decide, and how does that get integrated?
Or how is finality implemented at the relay chain level from the finality in the parachain, say?
I don't know too much about the details.
Okay.
I just know that basically you have different actors around the relay chain. One of them is the collators, that probably you have them in the left.
Yep.
That are in charge to collect the transaction from each parachain. And there's sort of, I think that they send them to the validators.
And sorry, when you say collect transactions, do you mean transactions that are finalized on the parachain, or do you mean they collect all the transactions? Like the UTXO, for example, do they collect all the unverified transactions as well?
Yeah, all the transactions.
Okay.
So they like propose a block. They propose a Polkadot block in a sense, right?
Yes, they sort of create a block, and that block is, I think that the hash is sort of what it actually goes into a relay chain block. So in the relay chain block, I think that you have the hashes of all the parachain blocks.
Okay.
Yes. And so, and since the collectors send the this transaction to the validators. I think that they have around 1,000 validators in the relay chain. And these are sort of shuffled between the parachains. And well, then they get the transaction, they sort of validate, they get the logic of the parachain, and they use this logic to validate the transaction. And they say, is everything okay? And they sort of, I think they create the relay chain block. More or less, that is the picture.
Okay.
It's all like working on top of proof of stake in some way, right?
Yes. Yes. And we use proof of stake with slashing. So in case that one of the validators create a malicious block, they will eventually get a slashing.
So they lose some of their stake.
Yeah.
But if we just come back, so you mentioned that Bitcoin is implemented somehow in this as a parachain, or the bridge is complete for Bitcoin, or close to being complete, maybe?
There is a bridge to Bitcoin. I don't really know how it works. And there are blockchains that implement proof of work.
Okay. So, yeah, so that was a question I had. So in proof of work, say the finality is determined probabilistically, right? Like there's no.
I think that for instance, in the case of connecting to Bitcoin,
yep.
I think that you have to wait for some amount of blocks.
I see. And then you just say this is final.
And then you say, okay, this is final.
So it can become a bottleneck for Polkadot in a way, right? Like I guess the scalability of Polkadot is as good as the scalability of its parachains.
I don't know how it works.
Maybe there's a delay, Carlos, no? Between.
I think that they're planning like a 6 seconds block in the relay chain, something like that.
Oh, I see.
Yes, and depending of you want to be totally secure, or you are just, I don't know, buying a coffee, that you can get the confirmation in a few seconds or more, because you might want to wait for the challenge to the validators. In case some validators detect a malicious block, they have to make a challenge, I think.
I think that's the fisherman blocks, no? The fisherman nodes.
I think that they don't have fisherman anymore.
Oh, they don't? Okay.
They made something less, a bit better, I think. But
okay.
Probably they're gonna keep the fisherman also, because it doesn't bother. But I think that there is a better way now to do it.
Yeah, I found that interesting. As a system.
I think I know they will have like select some validators to actually check the blocks.
Does Polkadot allow for Dapps to be developed?
Sorry?
Can you develop a Dapp on Polkadot? Basically a general smart contract on the relay chain, say.
Yeah, I think that is a very, a lot of people confuse that. It says that Polkadot doesn't have a smart contracts, but it's actually Polkadot has the parachains, and you can have different smart contracts
on different parachains
implementations inside each parachain.
Right.
And then on top of that, you can deploy Dapps.
Right. Yeah, so I guess Polkadot is just aggregating chains that can have whatever implementations they want.
Yes, it's very basic logic, and it's sort of giving the security through the dot token to the economical security to all the parachains. But yeah, the idea is that Polkadot the logic will be very basic to be sure that it's correct. And right now, I think that they support transfers in the relay chain, but probably that after will be separated to another specific parachain that will be in charge of the transfer.
I have maybe a slightly higher level question. So I guess there's the aspect of like communication between blockchains, right? That's one thing. Like I get that it's cool to send messages from Bitcoin to Ethereum or to some other blockchain. But then also it seems like Polkadot's implementing some level of like verification and sort of finality. So are those two things like, do those things need to go together, or can you have, for example, just a communication protocol that says, okay, well, if I trust Bitcoin, I'm going to send Bitcoin a message from Ethereum. If that works, that's fine. I don't need some kind of sort of overall consensus apart from the communication. Do you know what I mean?
Yes. Yeah.
Like what's Polkadot bringing in terms of like validation? Since if imagining you trust another parachain, why do you need Polkadot to give you some extra finality or validation?
I think that the point is that you don't really trust these parachains.
Okay.
Like okay, Bitcoin is a special case, let's say, but I think the point is that parachains don't have to worry about their security. Like they can have a token or not. The token can be wordless, but as long as they are connected to Polkadot, they get like all the security from the dot.
Oh, really? So I could have like a fork of blockchain that has like 3 miners on it, and it's like super easy to double spend on it. What happens if I plug it into Polkadot as a parachain? Does it somehow get more trustworthiness?
Yes, I guess, because you cannot revert the.
Okay, so whatever is decided in this, like if there's some fork later in this crappy Bitcoin that is used to double spend, if it's not authorized by Polkadot, then it doesn't get anyone else communicating with it. Okay, I see.
Yeah, I think it's something like that. Yeah, right.
So why do I want to own a Polkadot token? Like why would it? What value does it give? Is it something besides, or what transactions does it enable?
So basically, it allows you to deploy your blockchain and connect it to Polkadot.
Okay, so I have to pay in DOT tokens or dots to connect a blockchain to Polkadot.
Yes.
And it's like a.
Right now the system is like a users have to lend the DOT token to the parachain. So the parachains will implement different mechanisms, like maybe they will give you their own token or something to motivate you to lock your DOT into this parachain.
So you lease a slot basically with DOT tokens. And usually what happens, instead of doing an ICO or whatever, they tell people, buy DOT tokens, give them to us so we can lease the slot and you get a token on our parachain.
Yes, that's right.
That's the social mechanism that's occurring. Okay, I see. But but is there a limit on how many parachains I can have on the relay chain? Like right now it's 100, but is the goal for it to scale to 10 million or?
I think that you can have more than 100. But yeah, the goal is to sort of make it scale more. Maybe making some sort of cascade where you are like
parachains on like relay chains on relay chains.
Yeah, exactly.
I think cool. Isn't there like a bottleneck in terms of getting validators in the relay chain? I saw a video somewhere saying like it's hard to incentivize people to do this kind of relay chain validation. Like I'm wondering why it's not already unlimited, basically. Like, can't you just get more and more validators involved?
Yeah, I'm not sure. I think that Polkadot, they are growing the quantity of validators, I think, very slowly, because I think Polkadot, they should have like over 200, maybe 300 validators. And then we have Kusama, that Kusama is like the incentivized testnet for Polkadot. Kusama should have over 700 validators, maybe 800.
So I was looking a bit at Kusama. Kusama is it? It's a copy of Polkadot, or it's a testnet, like you said, or it has all the features implemented already?
Yeah, I think that the code is pretty much the same as Polkadot, but okay, the governance part of the
Governance
code,
part, okay, yeah,
has the parameters a little bit lower.
okay.
So you can sort of take decisions and move faster than Polkadot.
I see.
So in that sense, Polkadot is like the stable version of Kusama. Kusama is more sort of like a crazy and move fast, break things.
But I saw that Kusama has quite a huge economic value though. Like it's worth quite a lot for something that you want to break and like try to fix. You know,
like it's the tokens on there are on exchanges.
I mean, it's like 45th on market in terms of market cap, I think.
So you can exchange Kusama tokens on the exchange for Bitcoin.
I think. Well, I looked briefly at the coin market cap or whatever, but it has quite a bit. Its market cap is quite large. Like it's hundreds of millions of dollars, I think.
Okay.
Yeah, for a testnet, that seems kind of for a testnet where you want to break things and hope to fix them. It seems like quite a lot.
Yeah,
sounds like a bubble.
The main difference is that when they deploy code, every piece of code that is deployed to Polkadot has to pass out some audits, but to Kusama it's only tested locally. Let's say only Parity is testing it.
And when you say audits, you mean there's some decentralized way of checking if the code runs properly, or it's like a separate entity that checks and gives its stamp of approval?
Yes, different entities, companies check the code.
But these are predetermined. These are voted in, or it's just decided.
I don't know who decided this.
Okay, but it's some decided company that has some special key that says this software is okay to implement.
Yeah, they just read the code and say, okay, to us it doesn't have any bugs or that kind of thing.
Oh, so they're like a separate entity. Like are they actors on the blockchain?
Or they're just trusted individuals?
No, I mean it doesn't have anything to do with the deployment of the code. Like to update Polkadot, you need the community to vote using the DOT token. So yeah, it's not quite related. I guess these companies only check the code and say, okay, for us it's okay. But after that, deployment of the code depends on the community voting for that update.
Maybe that can lead into the consensus part of things. I don't know if you've looked into that somewhat. I mean, since we did our last episode was on proof of stake, I was wondering if we could like go a little bit deeper into how it works, at least in Polkadot.
I think that the consensus in Polkadot has like two main algorithms. Mm-hmm. It has Dave, that is in charge of producing blocks, and it has Grandpa. Grandpa is the other part that is in charge of finalizing these blocks. The nice property about Grandpa is that the validators vote on chains, not on blocks. So you can have like a partition for a long period of time. But then once the partition is solved, Grandpa can finalize like millions of blocks at the same time. Or very quick.
And it's all based on some sort of voting scheme, right?
Yes, they have to vote. And
just to
sort of 2/3 of the nodes to agree.
Mm-hmm.
So just to make sure I understand correctly, so Babe is like a proof of stake protocol where you can allowing people to propose blocks.
Yes.
And
Babe
then
is sort of the algorithm that kind of randomly select the validators that can produce the block in this slot.
With some pseudo-random number generator from hashes of previous blocks.
I think it's more fancy than that, more sophisticated.
Sure. Okay. Yeah. Yeah.
But is it actually somehow really random, or is it still pseudo-random? Maybe you've looked into that. I don't know.
I'm not sure, but probably I think that you don't have really time to attack the validators.
Okay.
Like suppose that they decide at this point in time the validator for the next slot. It will be like a very not so much time in advance. So you don't have time to actually attack these validators. I don't really know how much time, but it should be like 1 hour maybe.
Okay. But just the gist of it, Babe allows. Oh, go ahead, Carlos.
No, I was going to finish up on that. So the attack you're sort of hinting at is like, if I know in advance who the validators are going to be, I can like buy their keys or get their keys somehow and then put in a malicious block, right? Before the block gets approved?
Yeah, something like that. You always want to be some sort of random.
Yeah. Yeah, and I was looking into that. So, okay, so back to you, Perry.
And yes, okay.
Oh, go ahead if you have something to add.
No, I just wanted to say that, okay, there might be more than one validator selected for the slot, so you can have little forks. But then Grandpa comes and sort of finalize the common blocks.
But I guess do you really know like how many validators there are? Because I guess all you know is how many public keys I would imagine are validating, but you don't necessarily know like how many entities are actually controlling those keys, right?
Yeah, that's right. You don't know.
So there could be some scenario where like the Illuminati actually owns all the keys to the 1,000 Polkadot validators. Okay, I see.
Is that fixed though?
But if you actually check the validators in the list of validators that they have somewhere, you see that many validators belong to different blockchains companies, different actors. Like some are like companies that are specialized in validating. Some belong to members of the community, others belong to people that want to deploy the parachain. So it's quite diverse.
Okay.
And these are handed out, right?
Sorry?
Is there a vote to determine who gets to be a validator, or are these just given to people initially by Polkadot?
The number of validators is fixed.
Okay.
It depends on the amount of stake that you have.
I see.
So they take the top, I don't know, the top
1,000 or whatever.
1,000.
Yeah.
And those are allowed to
validate. I see. And somehow people know this list that you talked about. It's like it's just these validators have broadcasted that they're validators.
Yes.
Because in reality, you could be secret about it, right? You don't have to tell people you're a validator necessarily.
Yes, that's right. If you have enough dot.
Yeah.
But if you don't have, you sort of have to be a good validator and keep availability high.
Mm-hmm.
So people nominate you and lend you
their dots. Yeah, cool.
I wonder why is there a limit on the number of validators? Wouldn't you want it to be as large as possible?
Yes, but it's not really because you are limited by networking.
Okay.
At least in this sort of algorithms.
Oh, I see. Like there's some latency in communication, I guess, between the validators. Oh, I see. Okay, so then that's going to be a trade-off with scalability in some way.
Yeah, you have the voting rounds, and you want everything to be in a few seconds.
Right, right. Okay. So we have a real trade-off there, I guess. Like the more you want to reduce your probability of collusion, I guess, between validators, the more you lose in scalability, I guess, or networking.
Yes, that's right. There are some algorithms implemented to sort of try to distribute the stake over the validators. But anyways, if you don't know who is behind the key,
Yeah.
It's really hard.
Okay, cool.
Yeah, go on, Perry. Oh.
Yeah, I just wanted to circle back. So Babe is just a protocol that lets you propose new blocks, and then Grandpa, as I guess it mentions here, finalizes those blocks, right?
No, chain, I guess, no?
Or yeah, okay, sure, chain, well, that compose the blocks. So yeah, I was actually looking at this picture the other day, but so Babe produces all these yellow blocks, and then Grandpa comes in and makes the blocks that it wants black, meaning they're final.
Yes, that's right. The one that got like a 2/3 of the votes from the validators
are finalized. Okay, very cool.
Is that like I guess that's also a scalability choice, right? In some sense, everyone voting on a block at a time is, I guess, like working in not working in series versus working in parallel, or is there some advantage to having the sort of this like big forking structure?
Yeah, I think that it should be more scalable to do it this way.
Huh.
Because yeah, I guess that you can produce blocks really fast.
Yeah.
But doesn't this forking? Sorry, doesn't this forking just come from people being allocated the same slot? Like two block producers can produce a block in the same slot, so they each produce one, and then the Grandpa picks which one is valid.
Yes, that's right.
But while until Grandpa comes in, these are kind of like in limbo, right? These transactions aren't confirmed.
Yes.
They're not finalized. Yeah.
Yeah.
Yeah. Okay. Sure, but I think it's just the point is here that like after the first black block, after the last black block, there's 3 blocks, and that's just 3 different slots, 3 different people that were allocated the same slot. It's 3 different validators that were allowed to produce a block in at that height. And then on those blocks, for the next height, people are allowed to produce again until Grandpa comes in and just kills the chains that are that it decides are not valid with this 2/3 vote.
That's pretty interesting. So then you can't have hard forks, right? And I think that's one of the features of Polkadot.
Sorry, I didn't.
Oh yeah, my internet's not so great. So this means that you can't really have hard forks on Polkadot.
The way that Polkadot updates itself is with something that is they call forkless upgrade.
So this is a feature.
Yes, it's basically people voting on some logic that they want to deploy, and that is after once this logic is approved, it gets enacted as some block and is distributed to all the validators or nodes, and is executed sort of automatically. So the validator, the clients don't need to synchronize off chain.
Mm-hmm. So I guess it's like a bit of a tyranny in a sense. Because if there's a minority that wants something else, they're screwed. Like they can't just fork off and go do whatever they want, right?
Oh, I see what you're saying.
Yeah, that's true. Well, they can fork the repository of Polkadot.
I guess, yeah.
Yeah. Git is
everything.
Yeah.
Git is a blockchain, so it's fine.
Source, so.
Yeah.
Interesting.
But I guess they can fork and copy the past also, right?
Of course.
They can fork the repository, then copy all the past blocks, which is just like a hard fork, I guess, of the chain.
Yes.
And just to remind myself, this this consensus step is in the relay chain, right? Or is it also going on? Yeah, it is in the relay chain, right? The side chains, or sorry, the parachains are doing their own thing.
Yeah.
It determines about consensus. It's for me.
Definitely.
But maybe Carlos, can you hear us?
Yeah, I just cut out there for a bit. I'm back.
I see.
Mexican Wi-Fi.
Maybe we want to so Carlos and I attended a talk. We can ask you about this. Carlos and I attended a talk a couple of years ago about Cosmos, or not about Cosmos, but it was about
Tendermint?
one of the founders, Tendermint. Yeah. Can you maybe tell us the difference between what Polkadot is trying to do and what Cosmos is trying to do with Tendermint?
I don't know too much.
Okay.
But as far as I can tell, they're quite similar.
Like the goals are similar.
The goals are similar. They both have like some framework to build blockchains. But I think that people notice is that Polkadot has this shared security thing. And I think in Cosmos, you don't have it. Like
okay.
Yes, like if you want to communicate between chains, security of each blockchain,
Each individual chain.
Independent. And
okay. So that you're trading off some security that the relay chain and do you know if Ethereum has a plan to do this kind of sharding with individual chains, with separate chains, where you can implement different features?
I don't know.
Okay.
I think
No,
that it's pretty similar to Ethereum, but I think that
okay.
Ethereum, they have all the shards are similar, are the same.
That's what I'm saying, yeah.
I don't know if that means that they are all running the same virtual machine.
Okay.
Or something like that.
But you don't know if Ethereum has a plan to maybe make these shards being different?
No, I don't know. As far as I know, they have homogeneous sharding.
Okay.
Which I guess means that they are using the same virtual machine.
Yeah, that makes sense.
But in Polkadot, you can like implement whatever you want and optimize it the way you want.
Cool. Yeah. Carlos, I don't know if you have anything else.
Yeah, I think I was wondering, like, I don't know very much about sharding. If it's something that you've looked at a bit more, I'd be interested in getting like a bit more of an intuition on that. Maybe we can look at a picture or something as well.
I think the intuition is like having different CPUs all executing different transactions in parallel.
Mm-hmm. So you don't have like one continuous history at any point in time, I guess.
No, I think that they are sort of synchronized with the relay chain.
Oh, I see.
Yeah, the relay chain aggregates the history, right?
Yeah, it's like
it's like checkpoints.
Yeah. So basically, the sharding implementation on Polkadot is these parachains. Like, you can think of a parachain as a shard in a sense.
Yes.
Oh, okay. I see.
So I think homogeneous sharding means all the shards have the same protocol implemented, and then the relay chain would aggregate that history and make one block that tells you the history. But this heterogeneous sharding that Polkadot has is each parachain, each shard can have different rules. And the checkpoint on the relay chain gives you the aggregation of all these different transactions on these parachains.
Yeah.
Okay. All right. That makes sense.
So I think yeah. So homogeneous, I guess, sharding means same thing, same rules on every shard. Heterogeneous or parachains means different rules on every shard potentially.
Yes, I think that I don't know, but I think in Ethereum you have to build everything on top of the Ethereum virtual machine.
Okay.
But and Polkadot, I think that you sort of build everything on top of WebAssembly. So that is the difference.
Mm-hmm.
Like you have a Ethereum virtual machine that is sort of opinionated, is optimized for certain cases. And in Polkadot, you have the WebAssembly that is kind of more general, is more optimized. It can run at native speeds. And it's sort of, I think it was created by Microsoft, Google, Mozilla, all these big companies.
Very cool.
I have maybe more concrete question. Are there some like examples of Polkadot right now being used in some, concrete use case, with this idea of having parachains and all that? Or is it that's still kind of in the future?
As far as I know, that code is already implemented. They are in the audit phase. And right now they have a testnet that they call Rococo. And they are deploying parachains. I think that it should have like a 6 parachains, something like that now. And they will deploy more parachains in the next weeks. And I think that after the audit finish, and after Rococo run for a while, they're gonna start deploying the parachains to Kusama and then to Polkadot.
Okay, and I guess, is there like an maybe a vision for what's going to be like a very concrete use case for something like this? I guess there's still like a bit of development to go, but what's like the goal, like that, Polkadot's going to solve, apart from like just scalability of blockchains and communication? Like, I don't know, maybe now medical records are going to be able to communicate with insurance companies, or hospitals with insurance companies, or something like that,
Yeah. I don't really know. I think the most important thing about Polkadot is that people will be able to deploy their parachain with their very specific application. And they will also have like a sort of their own smart contract. So you can think about like a different Ethereum running in parallel, all able to sort of experiment. And they will probably, all of them will have like the governance model, because in Substrate we have the governance. So probably all of them will be able to evolve through governance and kind of experiment.
So it's almost like a United Nations.
And I think that maybe the most important application will be
tyrannical one.
will be the interaction between all of them. And yeah, probably we have to see how they are going to interact and how they are going to evolve.
Yeah, super interesting. Maybe one last question, unless Perry, you have one. I'm wondering, like, what are some of the kind of challenges that Polkadot is looking at right now? Some sort of big open problems that they're working on.
Or maybe it's a finished product already. I don't know.
Sorry?
Like, is it a finished product, or are there still things that have to get done? Maybe.
Like maybe at the level of like the protocol. Of course, there's implementation always, right? But like some sort of maybe more conceptual problem that needs to be solved.
I don't know. I don't work at yeah, I don't know.
No, that's fair. That's fair.
Yeah, I guess that in the next months, it will be just to see what happens with the parachains, how it works in real life, and sort of try to optimize all of it. And then...
Okay, cool. Is there anything else that you think we should know about Polkadot? Or did we cover most of it?
Is it something we can try out like pretty easily?
There, I think so. I think that you can use Substrate and deploy a blockchain in 5 minutes.
Cool.
Okay.
Like locally, I guess.
Yeah. Yeah, sure.
Add 1,000 parachains right now.
With a bit more of effort, probably you can deploy a blockchain to Rococo, or at least to the testnet version of Rococo.
And actually, yeah, on that, we were curious, like what kinds of features you can have on your blockchains. Like we've also been pretty interested in like ZK snarks and sort of things going in that direction. Is that something that Polkadot supports?
I think that they are planning to support. Like everything is like built through what they call pallets. Pallets is like the libraries in Polkadot in Substrate. So everyone, all the blockchain try to make a piece of code that are reusable. So if a blockchain create some sort of smart contract module, all the other blockchains can use it.
Oh, that's cool.
So it's funny to see that like pretty much all the parachains now share a lot of code, and all of them are gonna probably deploy smart contracts. They will have governance modules. Yeah, there is a lot of code sharing.
So basically, go ahead.
Yeah, go on, Perry.
So basically, if I create a parachain with some ZK snarks on it, I can then put that ZK snark module into Substrate, and then everyone can have ZK snarks if they wanted.
Yeah.
Right.
And actually, when the nice thing of putting it into Substrate is that you get like a lot of reviewers from different communities and from parity too. So it's like you are more sure that the code
I see.
is correct.
Right.
Oh, that's interesting.
So basically,
I hadn't thought of that.
ZK, we're just waiting for someone to create a ZK snark module for Substrate before it's implemented in Polkadot. So
it might be created already.
Oh, sure.
Yeah.
But it has potential for basically anything that we want.
Yeah, sure, because it's more like it's more general than Ethereum. So.
I see.
Yeah. And it's actually quite fast because it runs at native speed and using Rust, which is a very performant language.
Cool.
I think that's a good way to end it. More general than Ethereum. I like it.
The message from this random guy on internet.
Probably we should mention that Polkadot is developed by one of the founders of Ethereum,
Gavin Wood. Yeah.
He was ex-CTO, I think, and he wrote the yellow paper, I think, created Solidity. So if
he knows what he's doing.
He knows.
Yeah, very cool. Yeah, unless, like I said, unless you think there's something else we should know or that you want to add, I think that covers pretty much what we had as planned for questions. I don't know if Carlos has anything else.
Yeah, no, I think I'm good. I think I learned a lot. I'm quite happy.
Yeah. So I don't know, Marcio, if you have anything else to add,
no,
or something you think we should know about Polkadot, say.
It would be nice to cover maybe in a next episode, Substrate, which is
sure.
I think it's a very nice framework. It allows you to deploy to make a blockchain in a few months.
Do you think you can give us a tour of Substrate?
Well, he just said in the next episode.
Like a little demo? Yeah, for sure. At some point, I mean, I'd be really curious. Like, maybe we can actually like look at it and run it if it's something that's kind of doable. That
like
could
we
be
make
really
a
fun.
baby, make a baby.
You can make a blockchain in 1 hour.
That sounds super cool.
Let's do it, Marcio.
Let's do it. We will organize. We'll set up another episode.
Cool.
Blockchain from nothing.
We'll send you tokens. We'll send you tokens from that blockchain as a reward.
Nice.
A lot of tokens.
Cool.
Well, yeah. Go ahead. Thanks a lot, Marcio.
Jinx.
Yeah.
You're welcome.
Thanks a lot,
Thanks to-
Marcio, for taking the time.
Thanks to you too. It was really
And,
nice to participate.
Cool. And we'll keep you posted with anything else. And hopefully we'll see you for the next episode where we'll make a new blockchain.
Cool.
Thanks,
Okay.
Marcio. Enjoy your evening. Nice meeting you.
Yeah,
Thanks.
absolutely.
Have a nice day, guys.
Ciao.
See you later.
Bye.